In this video, we are going to look at the question 7s for the June CSEC Math exam for the years 2022 to 2019. So here I have my first question, which is question 7 for June 2022. We have, at an entertainment hall, tables and chairs can be arranged in two different ways as shown in the diagram below. So we have arrangement L here, and we have arrangement M here. So the rectangles are the tables, and the shaded squares, these small shaded squares, are the chairs. Now for part A, they want us to draw a diagram for 4 tables using arrangement L. So this here is arrangement L. Let's look at the pattern. So we have for a single table, we have on the short edge of the rectangle, we have 2 chairs, and on the long edge of the rectangle, we have 3 chairs. So we see that pattern continues here when we have 2 tables, on the short edge, 2 chairs, and on the long edge, 3 chairs. All right, same thing for this rectangle here. And the last pattern would be for 3 tables. So what we'll have to do is draw back the same pattern, exclude these 3 chairs, add the 4th rectangle, have 2 chairs on the short side of the rectangle, and 3 chairs on the long side. So what I'm going to do is draw back this diagram without the 3 chairs here. So here I have the diagram with 3 tables and excluding the 3 chairs on the long side. And now what I'm going to do is add a 4th table with 2 chairs on the short side, on either side, and 3 chairs on the long side. So I'm going to add that here now. And this would be a pattern for 4 tables using arrangement L. So now for part B, we have the number of chairs C that can be placed around a given number of tables T for either arrangements L or M forms a pattern. So this is the pattern they're talking about for arrangement L and arrangement M. The values for C for the first 3 diagrams for both arrangements are shown in the table below. So C is the number of chairs, and this is for arrangement L and arrangement M. T is the number of tables, so the number of tables here. Number of chairs for arrangement L, number of chairs for arrangement M. So these here will be the values we're talking about for the first 3 diagrams. Now they want us to study the pattern of numbers in each row of the table, and they want us to complete the rows numbered 1, 2, and 3. So that's rows 1 here, 2, and 3. Now let's have the arrangement L. We have 10, 14, 18. Now I notice a pattern here. 4 plus 10 is 14, and 4 plus 14 is 18. So this pattern here means we're going up by 4. So 4 plus 18 will give us this number here. So I'll have 18 plus 4 is equal to 22. Now on this side for arrangement M, 10 plus 6 is 16, and 16 plus 6 is 22. So for this missing one here, I'll have 22 plus 6. So 22 plus 6 will be equal to 28. So this is part 1 completed. 22 here and 28 here. So before I try to figure out part 2, where the number of chairs is 130 for arrangement M, and we got to figure out what the number of chairs for arrangement L when arrangement M is 130, and of course the number of tables. I'd like to do part 3 first, where I'll get a general formula for the number of chairs for arrangement L, and a general formula for the number of chairs for arrangement M. So first I'm going to go to arrangement L, so I'm going to put 4 arrangement L. We're going to have when the number of tables is 1, our first term is 10. When the number of tables is 2, our second term is 14. And when the number of tables is 3, our third term is 18. So I'll have 10, 14, 18. Of course, the fourth term was 22. All right, when the number of tables was 4, the fourth term was 22. And I'm going to call the 10 my first term. I'm going to call that T1. That means first term. 14 is the second term. I'll call that T2. 18 is T3, which is our third term. And 22 is T4, which is our fourth term. So notice the 1, 2, 3, and 4 coinciding with the number of tables. 1, 2, 3, 4. And these are the terms. First, second, third, fourth. Now we notice for arrangement L, the number of chairs goes up by 4 every time you add a table. All right, so from 10 to 14, 14 to 18, the difference is 4, right? So what I'm going to say is, for my first term, T1, I'm going to use that number that we keep going up by, which is 4. I'm going to multiply it by the number of tables, which is 1. because I'm dealing with my first term, which is 10, and that's when the number of tables is 1. And then 4 times 1 is 4. So I'm going to ask myself, what do I need to add to 4 or subtract from 4 to get 10? Now 4 plus 6 is 10. So I'll need to add 6. So if I add 6 here, and let's work it out. 4 by 1 is 4 plus 6. You would get 10, which is our first term. Now let's see if that pattern holds for the second term. So my second term, I'll call that T2. I'll have 4 because the pattern keeps going up by 4 times the number of tables, which is 2 this time. 2 tables, and my second term is 14. Now 4 2s are 8. What must I add to 8 or subtract from 8 to get 14? Obviously, I have to add something to 8 to get 14. If I add 6 to 8, I will get 14. So 4 by 2 plus 6. So 8 plus 6 would give 14. And that's my second term. Now let's check to see if it works for the third term, which is 18. We have our third term. So 4, because the pattern keeps going up by 4. The number of tables is 3. And that's our third term. 4 times 3 is 12. And what must I do to 12? Meaning add something to it or take away something from it to get 18, because 18 is our third term. Obviously, 12 plus 6 would give you 18. So now that we established that this formula holds for our first 3 terms, let's apply it to the nth term. So you can clearly see we are multiplying 4 times the number of tables plus 6 to get the number of chairs for arrangement L. So therefore, when the number of tables is n, my number of chairs for arrangement L will be 4 times the number of tables, which is n, plus 6. And that just means my nth term is equal to 4n plus 6. So this will be the nth term here for this pattern. Now let's do the same thing for arrangement M. All right, for arrangement M, we have first term is 10, second term is 16, third term is 22, fourth term is 28. So let's write that out. That is 10, then 16, then 22, then 28. So here my first term is 10, second term is 16. Of course, that's when the number of tables is 2. Third term is 22. Fourth term is 28. So we get our first term and the number of tables is 1. Second term and the number of tables is 2. Third term and the number of tables is 3. And the fourth term and the number of tables is 4. Now here the pattern is we're going up by 6 all the time, right? 10 plus 6 is 16. 16 plus 6 is 22. 22 plus 6 is 28. So for my first term, I would say 6 times the number of tables, which is 1, which will give 6. And what must I do to 6? Whether we add something to it or take away something from it to get this 10. Right? So obviously 6 plus 4 is 10, so I'll have to add 4. So that'll be 6 plus 4, which will give you 10. So that's why my first term is 10. Let's check it for the second term. So I'll have 6 times the number of tables, which is 2. 6 2s are 12. What must I do to 12 to get 16? Add 4. So you can see 12 plus 4 is 16, and that's your second term. By now you should be getting the hang of it. So you can see for your third term, which is 22, the number of tables is 3. So 6 times 3 is 18. And if you add 4 to 18, you would get 22. So the pattern would be when the number of tables is n for arrangement M, would be 6 times the number of tables, which would be n, and you have to add 4. So my nth term will be 6 times n plus 4. So now that I established part 3, which is the nth term, which is the general formula for the number of chairs for arrangement L and M, I can focus on part 2 now. So this 1/3 is the number of chairs for arrangement M. Now we need to know how many tables we need to get 130 chairs using arrangement M. That's the first thing we need to do. Now we know n is the number of tables. So I can put a 6n plus 4 is equal to 1/3 and find out what's n, and I'll know the number of tables to obtain 1/3 chairs using arrangement M. So for part 2, I will put the 6n plus 4 is equal to 130, because this is a general formula to give me the number of chairs for arrangement M. And we have 130 chairs, and we want to know what term it is, which is N. So I'm going to carry across the 4. So we have 130 take away 4. So we're going to have 6N is equal to 126. So we're going to have N is equal to 126 divided by 6. So N is equal to 21. So what does that tell us? It tells us that for part 2 here, the number of tables is 21 when the number of chairs is 130. So I'm going to put 21 here. So now that we know that the number of tables is 21 for the number of chairs to be 130 for arrangement M, now remember the number of tables is N in our formula. So we just have to use this formula now for arrangement L, replace the N with 21, and we get the number of chairs for arrangement L. So we have Tn, and this is for arrangement L, is equal to 4n plus 6. And the 21st term, so T21, means replacing the n with 21. So 4 by 21 plus 6. And 4 by 21 is 84. So we're going to have 84 plus 6. And that's equal to 90. So T21 for arrangement M is equal to 90. So that means when the number of tables is 21, for arrangement L, we'll have 90 chairs. Now for part C of this question, we have Leon needs to arrange tables to seat 70 people. So that means he needs 70 chairs for a birthday party. Which of the arrangements, L or M, will allow him to rent the least number of tables? Use calculations to justify your answer. So what we're going to do for this question is go back here, where we have, this is our general formula for the number of chairs for arrangement L, where N is the number of tables, and we know we want to seat 70 persons. For arrangement M, this is the general formula that will give you the number of chairs, where N is the number of tables, and you know you want to seat 70 persons as well. So I'll put this general formula equal to 70, both of them equal to 70, solve for N, which will give me the number of tables needed to seat 70 persons for arrangement L and arrangement M. So let's start with L first, which is 4n plus 6. So for arrangement L, we have 4n plus 6 is equal to 70. So we transfer the positive 6 across and turn to negative 6. So we have 4n is equal to 70, take away 6. So 4n is equal to 64. And now we transfer the 4 across the equal sign and we'll turn from multiplication, because 4 multiplied by n, to division. So we have 64 divided by 4. So we have n is equal to 16. So for arrangement L, we'll need 16 tables to seat 70 persons. So 16 tables to seat 70 persons. So now for arrangement M, we go back to our general formula here, which is 6n plus 4, which is the general formula for the number of chairs for arrangement M. And of course, we want to have 70 chairs. So we're going to have 6n plus 4 is equal to 70. So we transfer the positive 4 across the equal sign and we'll turn to negative 4. So we have 6n is equal to 70 take away 4. So 6n is equal to 66. So now we have the 6 multiplied by the n. So when we transfer it across the equal sign, the operation will change to division, and we'll have 66 divided by 6. So n is equal to 11. So that means we need 11 tables to seat 70 persons using arrangement M. So the question was asking which arrangements, L or M, will allow him to use the least number of tables, of course, to seat 70 people. And of course, that answer will be arrangement M, because 11 tables is less than 16 tables. So arrangement M will allow him to rent the least number of tables. And that's question 7 for June 2022. So now let's move on to question 7 for June 2021. So we have that the first three figures in a sequence of shapes formed by connecting lines of unit length are shown below. So we have figure 1, figure 2, figure 3. So what I want us to do here for part A is to draw figure 4 of the pattern in the space provided above. So what I'll do is skip 2 blocks and draw back figure 3 pattern. So now that I've drawn over figure 3 pattern, I'll add the square that comes here and the triangle that comes above it. And this is the solution for part A. So for part B, we have that the number of lines L in the shape and the perimeter P of the shape follow a pattern. Study the pattern of numbers in each row of the table below and answer the questions that follow. So here we want to complete the table showing the number of lines and perimeter for each figure. So we have the table here. This column gives the number of lines and this column gives the perimeter. Now for this one, I'd like to find the general formula for the nth term and then I'll fill out the rest. So let's see the pattern here, 6, 11, 16. So for L, we have 6, 11, 16. So this is my first term, second term, third term. Now let's see. 6 plus 5 is 11. 11 plus 5 is 16. So you keep going up by 5. So I'm going to say for my first term, I'm going to use that 5 multiplied by 1 because it's my first term, 1. And that's the first figure, 1. 6 is my first term for L. And 5 by 1 is 5. So I'm going to ask myself, what must I do to 5 to get 6? Would I be add something or subtract something? So obviously I had to add 1 to 5 to get 6. So I'll add 1. So that's 5 plus 1, which is 6. So my first term is 6. So I establish a formula. Let's see if it works for the second term. So for my second term, because I'm going up by 5, I have the 5. I'm multiplying by 2 because it's my second term. 5 2s are 10. My second term is 11. What must I do to 10? Meaning add or subtract to get 11. Well, add 1. So 5 by 2 is 10 plus 1, which is 11. So that's my second term being 11. So my third term is 16. So if I say 5 times 3, I'll get 15 and add 1, which will be 16. So this formula holds 5 times the figure number plus 1. So when the figure number is n, we'll have my nth term will be 5 times the figure number, which will be n plus 1. So I'll come and write here 5n plus 1. So this will be my general formula for the number of lines when we have the nth figure. So now I'll find the general formula for the perimeter for the nth figure. So for the perimeter, our pattern is 5, 8, 11. So that's 5, 8, 11, and so on. Now let's see the pattern here. 5 plus 3 is 8. 8 plus 3 is 11, so we're going up by 3. So this will be my first term, second term, third term. So for my first term here, because we're going up by 3, I'll use 3 times 1, which will be my first term. Now 3 times 1 is 3. What must I add to 3 or subtract from 3 to get 5? I'll add 2. 3 plus 2 is 5. That's why I get first term being 5. Now let's check the second term. So 3 because we're going up by 3 all the time. 2 because it's our second term. 3 2s are 6. What must I add to 6 or subtract from 6 to get 8? Well, add 2. 6 plus 2 is 8. Alright, so far it seems our formula is holding. So now let's check it for 11, which will be our third term. So that's 3 times the figure number plus 2, right? So 3 times 3, because the figure number here will be 3. which will be 9, plus 2 is 11. So the formula holds. So a general formula for nth term would be 3 times n plus 2. So a general formula for the perimeter when we have the nth figure would be 3 times n plus 2. So now let's answer the question for part 1 when the figure number is 5. So for part 1, for the number of lines, which would be L, all right, our fifth term would be 5 times n, which would be 5, plus 1, which would be 25 plus 1, which is equal to 26. And that's why we know 26 come in here. And for the perimeter, the fifth term will be 3 times 5 plus 2. So that's 15 plus 2, which is equal to 17. And that's our fifth term for the perimeter. And that's why we know 17 come in here. And now for part 2, when the number of lines is 66. All right, so remember this is the general formula for the number of lines. So if you put this general formula equal to 66 and solve for n, you will get what figure it is. All right? So for part 2, I'm going to put 5n plus 1 is equal to 66. Solve for n. So I'll transfer across the positive 1, I'll turn to negative 1. So I'll have 5n is equal to 66, take away 1. So 5n is equal to 65. Transfer the 5 across, the operation change from 5 multiplied by n to n is equal to 65 divided by 5. Opposite of multiplication is division. So n is equal to 13. So I'll be putting 13 here. And now that we know the 13th term will give us 66 for the number of lines, we just have to figure out what is the 13th term for the perimeter. So let's remember for the perimeter, we have Tn is equal to 3n plus 2. This is for the perimeter. So a 13th term, T13, will be replacing the n with 13. And 3 times 13 is 39, plus 2, which will give us 41. So a 13th term for the perimeter is 41. And that's why we know 41 come in here. So now for part C, we want to write a simplified expression in terms of n for a difference d between the number of lines and the perimeter of any figure n. So what we're going to say here is that d is equal to the difference between the number of lines and the perimeter. And the general formula for the number of lines is 5n plus 1, and the general formula for the perimeter is 3n plus 2. So d is going to be equal to 5n plus 1, take away this 3n plus 2. So we're going to have 5n plus 1, take away this 3n plus 2. So d is going to be equal to, well, 5n plus 1. You multiply this negative sign by the 3n, and you're going to get negative 3n. You multiply the negative sign by positive 2, and you're going to get negative 2. So now you're going to bring your like terms together. So what I'm going to do is have the 5n remain on the n here. I'm going to take the negative 3n and bring it next to the 5n. Like that. So now I have positive 1, take away 2. So I'll have d is equal to 5n take away 3n, which is 2n, and 1 take away 2, which is negative 1. And this will be my simplified expression for d, which is the difference between the number of lines and the perimeter in terms of n. So now moving on to question 7 for June 2019. We have the nth term Tn of a sequence is given by Tn is equal to 3n squared take away 2. We want to show that the first term of the sequence is equal to 1. Now, since we've seen that the nth term is Tn, it means the first term is going to be T1 when n is equal to 1. So I'm going to write Tn is equal to 3n squared take away 2. So my first term, which will be T1, will be 3 times 1 squared take away 2. Now, we all know with BODMAS, you must work powers first before you do any of the 4 operations. So 1 squared is 1. So I'm going to have 3 times 1. Take away 2, 3 times 1 is 3, take away 2, which is equal to 1. So my first term T1 is equal to 1. And that's the first question, to show that the first term of the sequence is equal to 1. Now here for part 2, they want to know what is the third term of the sequence. So just like the nth term is Tn, the first term is T1, the third term will be T3, which will mean replacing the n with 3. So again, I'm going to write Tn is equal to 3n squared, take away 2. So the third term T3 is equal to 3 times 3 squared, take away 2. So again, powers first before any of the 4 operations. So 3 squared is 9. BODMAS says we must multiply first before we could subtract. So 3 by 9 is 27. Take away 2, which will be equal to 25. So our third term is equal to 25. Now for part 3 of this question, given that Tn is equal to 145, what is the value of n? So just take the formula for Tn, put it equal to 145, and solve for n. So I'll have Tn is equal to 145, and Tn is equal to 3n squared, take away 2. That'll be equal to 145. Transfer the negative 2 across equal sign, will turn to positive 2. So we have 145 plus 2. So we're going to have 3n squared is equal to 147. Now we have 3 multiplied by n squared. So when it transfers 3 across equal sign, the operation will change to division. So we have n squared is equal to 147 divided by 3. So n squared is equal to, and 147 divided by 3 is equal to 49. Now see that n squared is equal to 49. N would be equal to a plus or minus square root of 49. So n is equal to plus or minus 7. Now seeing that is a sequence, n cannot be negative because whatever is the first number would be the first term. It wouldn't be a negative number, it would be 1. And the number after that would be a second term, and you keep counting like that. So n would never be negative. So since n is positive, n is equal to 7. So moving on to part B now, we have the first 8 terms of another sequence, with the nth term being un are, well, 1, 1, 2, 3, 5, 8, 13, 21. So here it's saying that u1 like this, so this will be first term is this u1, which is 1. u2 like this is the second term, which is this 1 here. And they're saying this is the formula for the nth term, for n is greater than or equal to 3. So what they did now is give us an example of how to use this un. They say the 5th and 7th terms are, so u5. So that was when n is 5, you replace the n here at 5. 5 take away 1 is 4, that way I have u4. And n take away 2, so that'll be 5 take away 2, which is 3, that's why I have u3. And then you come here, where's u4 and u3? So first term, second term, third term, fourth term. So the third term is 2, and the fourth term is 3. That's why for the third term you have 2, and the fourth term you have 3, and that's why it's 3 plus 2 is equal to 5. Same thing when you have u7. Alright, so let's write this out like this so that I can clearly see terms. So u1, first term, second term is 1, third term is 2, fourth term is 3, fifth term is 5, sixth term is 8, seventh term is 13, eighth term is 21. So let's look at this example for u7. That's when n is 7. So n take away 1, so this will be 6 in here, and n take away 2, that'll be 7 take away 2, which will be 5 in here. So that'll be u6 plus u5, and that's why that'll be u6 plus u5 like this. What is the sixth term? That's 8. That's why you have 8 here. Plus the fifth term. What's the fifth term? That's u5, and that's a 5, and that's why you have 5 here. So 8 plus 5 is 13. So now for part 1, they want us to write down the next 2 terms in the sequence, u9 and u10. So the 9th term and the 10th term. So I'm going to write down the formula. un is equal to un take away 1 plus un take away 2. So the 9th term, that'll be u9. So that'll be u9 take away 1 plus u9 take away 2. And 9 take away 1 is 8. and 9 take away 2 is 7. So what we're saying is that the 9th term is equal to the 8th term plus the 7th term. Now we just come here and see that the 8th term is 21 and the 7th term is 13. So we're going to have 21 plus 13. So 21 plus 13 is 34. So our 9th term is equal to 34. So I just wrote it over here that my 9th term is equal to 34. Now we're going to find our 10th term, U10. So let's go and write the formula first. So UN is equal to UN take away 1 plus UN take away 2. So now U10, the 10th term, that'll be U10 take away 1. I mean, can I write 9 one time, yeah? And then for UN take away 2, can I write 8 one time? 10 take away 2. All right, so this will be our 10 take away 1 is 9. So that'll be our 9th term plus 10 take away 2 is 8. That'll be our 8th term. Now we just figure out what the 9th term is. The 9th term is 34. So for the 9th term here, you put in 34. So U9 is 34. And then our 8th term, you could find that right here. Our 8th term is 21. So 21. So now 34 plus 21 is 55. So our 10th term is 55. Now for part 2, they want to know which term in the sequence is sum of U18 and U19. So I just brought back the formula here. And now let's look at something. The 10th term was the 9th term plus the 8th term. So you see 10, 9, 8. The 9th term, U9, was equal to the 8th term plus the 7th term. 9, 8, 7. See that pattern? We can say 7, 8, 9 or 8, 9, 10. So when you come here and ask which term in the sequence is sum of U18 and U19, well, 18, 19, 20. All right, so U20 will be equal to U20 take away 1 plus U20 take away 2, right, according to the formula. N take away 1, N take away 2, and N is 20, right? So that'll be U19 plus U18. So that'll be U20. All right, so my 20th term is equal to the sum of the 19th and the 18th term. Now here for part 3, I want to show that the 20th term take away the 19th term is equal to the 19th term take away 17th term. Now we just obtained a formula for U20, which is 19 plus 18. And of course, U19 will just be U18 plus U17. So I'm just going to write that out, that note that the 19th term, just following the pattern, will be the 18th term plus the 17th term. So if I were to have my 20th term, take away my 19th term, that would be U20 is U19 plus U18. So U19, which is the 19th term, plus the 18th term, take away, open brackets, the 19th term U19, which would be U18 plus U17. Close brackets. So now if I multiply this negative sign by U18 and U17, I would get U19 plus U18, and we multiply negative sign by that, and we get negative U18, and negative by positive U17, and we get negative U17. What we have here, positive U18 take away U18, so that'll just give you 0, and you remain with U19 take away U17. And that's what it asks to show, that the 20th term take away the 19th term is equal to the 19th take away the 17th. So here we have the 20th term, take away the 19th term is equal to the 19th term, take away the 17th term. All right, just remember this here will cancel out and give 0. The same thing, take away the same thing, the answer is 0. So the 18th term, take away the 18th term, you're going to get 0 here. So you're going to remove the 19th term and the 17th term. I'll just shade that this will give you 0. And that's it for this video.